Your brain size and your head size, like your height, are determined by Good morning, friends! In this video, we're going to learn how brain size directly impacts our intelligence. But before we do, please subscribe to the channel if you're not already, like the video, and comment on the video for the sake of the algorithm. Now let's get started. First of all, let's discuss the importance of this subject and why I'm making a video on it. It's long been known that brain size distinguished humans from other species. Our brain size, for example, distinguishes us from non-primates and within the primate species in particular. Over the last 3 million years, our brain size has tripled. An assumption that somewhat follows from that observation is that human brain size may be responsible for human beings' different ability with intellectual reasoning. But what's not so intuitive is the fact that human brain size within humans determines how intelligent human beings are. In fact, among all anatomical measurements of humans, head size, which is a noisy proxy for brain volume, is the strongest correlate of human intelligence. It generally has a correlation coefficient of around 0.25 for those that are statistically familiar. Now, it makes sense that brain size within humans would be associated with our differential intelligences, because brain size is somewhat a proxy of our actual number of cells in the brain. And so intuitively, it determines how much ability, how much potential we have for cognitive reasoning. But then what follows is the curious question of whether human brain size is influenced mainly by nature, by our genetics, or also by our environment, nurture. Let's deal with the nature part first. It seems that there are genes that predispose humans to both having a larger brain and toward being more intelligent. So these genes are associated with both intelligence and brain volume. Interestingly, many of these genes clearly have a role in cellular replication and differentiation in the body. For example, many of these genes are associated with the mTOR process, which I mentioned many times in the channel, mTOR being the mechanistic target of rapamycin, a major growth pathway in the body. Many of these genes are involved in mTOR's activities. For example, one of these genes is a tyrosine kinase receptor. Those are the receptors that are blocked by anti-cancer drugs, chemotherapeutics. Some of the genes are involved in epidermal growth factor transcription, a growth factor involved in cellular proliferation and differentiation. And in general, this explains to us how the actual genes that predispose people toward having larger brains can directly be involved in what's called neurogenesis. Neurogenesis is the creation of new neurons in the brain, where neurons are the cells of the nervous system. So brain size is determined by nature, but it's also determined by nurture. For example, there are studies on children that show that children who are reared by a step parent, in addition to a birth parent, have smaller heads than children who are raised by two birth parents. Also, children who have resource constraints in childhood, like for example low protein in their diet, have smaller heads. And in fact, head size is a more sensitive predictor of growth restraints in childhood than height. Shocking, I know. So as you can see, brain size is determined by genetic factors and by environment in development. And therefore, it becomes a little bit difficult to tease out or hope to tease out causality. Causality is trying to understand the causal relationships. Does brain volume, brain size, directly cause greater intelligence? Or is it, for example, intelligent people are, due to their intelligence, develop larger brains? This is called reverse causation. Or, for example, pleiotropy, in which some other factor causes both a larger brain and more intelligence. One way one can investigate the causal relationships is a study of siblings. That's what we're going to discuss in this video. Sibling studies can more accentuate the genetic influences on outcomes rather than the environmental influences, by holding the environmental influences somewhat more constant. And finally, this takes us to the 2020 study, which I wanted to discuss with you guys. In this study, two data sets were used. First, what was determined is that head size robustly was associated with intelligence, irrespective of measurement criteria. So intelligence could be judged by different IQ tests, and head or brain size could be estimated through different mechanisms, including fMRI-based estimation of brain volume, as well as a simple measurement of the circumference of the ahead. This means that within siblings, the sibling that had a larger estimation of their brain size tended to have a higher IQ. Again, in this study, it was confirmed that some genes that predispose people toward having larger brains also predispose people toward having higher intelligence. But in this study, using the latent causal variable method, it was determined that it's most likely the case that those genes had a causal flow, in that those genes caused a larger brain, which in turn caused greater intelligence. Not entirely, but largely so, such that the causal flow was from genes toward bigger brains, and bigger brains produced more intelligence. In fact, as a side note, not only IQ, but also years of educational attainment were both associated with brain size in this way, such that brain size was thought to causally play a role in the number of years of education somebody had. And this is particularly interesting to note because it was recently discovered, and I was thinking about making a video on this. For those that don't know, the years of higher education you have past undergrad is associated with your IQ later in life. So it's thought to be the case that people can get higher IQs, that is their true measure of cognitive intelligence, through years of advanced educational training. But it turns out, a recent paper discovered, it turns out that there are genetic predispositions which determine how much somebody's IQ can elevate from years of advanced education in the first place. So even the people that are trying hard to get smarter need genetics on their side to do so. Alright friends, let's summarize the key takeaways from this video. First, your brain size and your head size, like your height, are determined by your genetics and protein consumption in your childhood years. Second, your brain size and your intelligence are both determined by common genes, but it's likely the case that those common genes make you have a bigger brain, which in turn makes you more intelligent. And third, finally, for those that haven't watched my serotonergic series, this is all quite interesting because I've long had a suspicion that bigger brains could be more intelligent, but this would be very difficult to show in intervention studies that are longitudinal. So I've always had this suspicion that increasing your brain size through increasing growth factors in the brain could increase your potential for maximum intelligence during your lifetime, for achieving your own maximal level of intelligence. And it seems we finally have evidence of this. Brain size literally determines a person's intelligence. Anyway friends, I look forward to seeing you again this afternoon.